Hi, I'm Martin Fowler, a software development loudmouth. My most recent book with my colleague Pramod is NoSQL Distilled. One of the things that makes me a loudmouth is that I'm the editor of a signature series for Addison-Wesley. Signature series appeared, I'm not quite sure really where the idea came up, somewhere in the bowels of Addison-Wesley. They thought it would maybe a good idea to get some of their more successful, or as I think of it, more lucky authors to sponsor series of books. I was one of the people so asked, as was Kent Beck, and the idea was that each author would have the chance to frame a series of books on topics that they felt were worthy of whatever meant for their series. The various authors, we don't really talk about how we handle our series at all. I've actually never spoken about this even to Kent, who I know relatively well. And we all take our individual take on it. For me, the interest in being an editor of a signature series is it gives me the opportunity to highlight books that otherwise I don't think would be as popular as they might be, and to be able to give them some extra boost. Basically because I'm saying I think this is a book that is really valuable and important. So I was actually very keen to take on this role of a signature series editor because I felt it would be able to give some good publicity and help build up the profile of authors who otherwise wouldn't be as well known. My signature series started with my own book, Patterns of Enterprise Application Architecture. The signature series idea was mooted at around the time that book came out. And the idea behind that book, of course, was to try and capture some of the common things that I'd seen done in enterprise applications in such a way that new people coming into this field would be able to learn about them more quickly, and also so that experienced people in the field would have a book that they could use to help them pass on their knowledge. One of the things that we find in software development, as in many technical areas, is that the people who really know how to do it aren't necessarily that good at being able to pass it on. I mean, those are really separate skills. And the value of a book like mine, or indeed any book like this, is that it can be a tool to help you communicate about something you know well, because it saves you having to think of how to communicate it yourself. It was interesting that at the same time as I was working on Patterns of Enterprise Application Architecture, somebody else was taking a different slant at architecture. This someone else was Luke Homan, and he was very interested in topics that didn't usually get talked about under the terms of architecture. And he was working on a book in this area, and I quickly got hold of him and said, how about getting into the same series that I'm just about starting? I think it would be a good fit. And that led to the book Beyond Software Architecture. And this moves beyond the typical architecture discussions to things like licensing, billing, branding, topics that were typically off the syllabus in architecture terminology, but actually are very relevant for software architects. So Luke's book and my book were the first two books in my series. The next thing that really caught my attention was in the area of messaging. My colleague at the time, Gregor Hope, was very active in working in messaging systems, doing a lot of work that we were doing with integration in messaging tools, TIBCO, that kind of thing. And he was interested in trying to capture good ways of working, and patterns were a natural way of doing that, and he came to me and talked to me about making a book about this. At the same time, Bobby Wolf, who I knew slightly, was doing something similar. And Bobby had talked to a mutual friend of ours, Kyle Brown, and Kyle talked to me, and we decided that it was necessary that Gregor and Bobby be united and have a shotgun marriage to put their ideas together. The resulting book is Enterprise Integration Patterns, and it is a really solid, I think, overview of how you look at messaging systems, how you think about messaging systems, and how you design with them and integrate systems with them. Now, my refactoring book was too early to go in the signature series. It's certainly a book I would put in the signature series now, but it came out before the signature series was around. Patterns are, of course, a common theme of what I and many of my co-authors in the series use as a way of communicating. So it seems natural to kind of think about whether these two topics go together. And in fact, anybody who knows anything about refactoring and patterns knows they very much do go together. You often introduce patterns into a system design gradually through a process of refactoring. What Josh Kerievsky has done with the Refactoring to Patterns book is describe how that system works. He takes many of the well-known patterns, for instance, the Ganga 4 patterns, and talks about how you can gradually refactor to get there. And that's very much based on Josh's experience building systems. He has since gone on to build a whole e-learning website stuff at Industrial Logic. And the patterns that he describes in the book are very much based on that work. In fact, one of the things that Josh is very proud of is that in the book he uses very realistic examples where he actually talks about the things that he did in order to introduce patterns into his work. Refactoring is important for code, but it also is very important when it comes to data. In fact, right at the beginning of the early days of when ThoughtWorks started using agile development, one of the initial questions was, well, it's all very well to talk about this flexible evolutionary design with lots of refactoring, but how on earth do you do that if you're going to connect this to a relational database? In fact, several people told us you just flat out couldn't do it. You had to come up with a database schema at the beginning and get it settled before you could actually do any serious software development on it. Fortunately, one of the ThoughtWorks team was Pramod. And Pramod has always been a very different kind of database guy to the usual database guy. For a start, he's interested in the programming side of things. In fact, he very much wants to cross that gap between the data and the programming side. And he was very keen on figuring out how the database could handle this kind of evolutionary approach. And the approach that he developed that we used on projects around 10 years or so ago and have been using ever since was basically to build up the database gradually through a system of structured migrations where each individual migration makes a very small change to the database that alters both its schema and also the data captured within it. So by applying the migrations, you can evolve both the database schema and also the data that's inside the database. So Pramod was very keen to turn this thinking and spread it more widely, and he ran into Scott Ambler. Now, Scott Ambler is another of these rare people that tries to cross that programming data divide. And so they got together and worked on the book Refactoring Databases. And the Refactoring Databases book essentially looks at these transformations, these individual changes that you can make to a database, and catalogs them in a very similar way to the fact that the way in which I cataloged programming changes in the original Refactoring book. So the idea is that this allows you to use the same evolutionary design techniques on your databases. This evolutionary approach to databases is a huge deal to us at ThoughtWorks. Almost every project we use uses it. But it's sad to me that when I talk to people outside, these techniques really aren't terribly well known. And they ought to be a lot better known. And this book is a very good way to find out more about it. Back in the mid-90s, I was lucky enough to work on what's considered to be the birth project of extreme programming, the C3 system at Chrysler, where Kent Beck took the ideas that he'd developed on many years of consulting and pulled them together into a coherent approach to software development that became known as extreme programming. Extreme programming was the first really popular agile approach, and there are many of us who still consider that it is probably the most influential and important of the named agile methodologies. A vital part of what we did on that project was continuous integration. Every day, every developer on the team would ensure that what they were working on was integrated with what everybody else was working on. And this is really important. I still remember the very first software development project I ever saw, which was even longer ago in some warehouse in the north of England. And I was being shown around because I joined the company as an intern. And I was told, well, this project, it's been working for a couple of years. They finished the system 6 months ago, and they're currently integrating. And the lesson I learned from that is that integration is some horrible, complex thing that you want to avoid doing until the last possible moment. And really that's why it ends up being such a problem, because people leave it to the last possible moment. On the other hand, if you integrate continuously, like we did at C3 using continuous integration, every day everybody is integrating, integration actually becomes very straightforward. And that's, in fact, what we do on pretty much all our projects at ThoughtWorks. We use continuous integration, we don't have big integration phases, and everybody is able to work effectively together, even on projects with 100 people on the team across multiple sites around the world. Now, although we have a lot of experience with continuous integration at ThoughtWorks, no one actually got around to writing it up within ThoughtWorks. Fortunately, Paul Duval stepped up, and he ended up writing the book on continuous integration. It really goes into the details of how you go through this continuous integration process, various edge cases and things that you have to deal with, and really acts as a guide to that process. So continuous integration is really valuable because it provides this way that a development team can all keep in step with each other by integrating with each other. And we got pretty good at that at ThoughtWorks quite a few years ago. But what we found was that it was one thing to integrate within the development environment. In order to really make this stuff work, you actually have to take stuff out of a development environment and put it into production. After all, you're not really done until your software is there in production, earning value for the organization. And getting from continuously integrated to continuously delivered into production is actually quite a big step in its own right. And that's what led to the book Continuous Delivery, written by Jez Humble, who is a colleague of mine, and Dave Fowler, who was a colleague, has now done other exciting things. But the two of them between them, I think, have provided a really good guide to getting beyond what happens with continuous integration and getting it out into delivery. It captures a lot of techniques centered around the idea of a deployment pipeline, which has a series of phases that lead you from source code flying around in a repository to a gradually increasing range of tests to give you confidence in that code, and then automatically deploying into automatically configured production environments. When you use continuous delivery effectively, what it allows you to do is to deliver more frequently, have more rapid release cycles. It allows you to lower the risk of delivery because of the fact it's rather counterintuitive, but if you deliver more rapidly and use these kind of automated techniques, your chances of something going badly wrong that you can't recover from are greatly reduced. It's a big reduction in risk. And what that means also is that you don't have to go in at Sunday night till all hours of the morning trying to get a deployment done. Our ideal for deployments is that you should be able to do them at 5 o'clock on a Friday and then go down to the pub, because we're British and there's one thing that Brits have to do is go down to the pub on a Friday evening. So we can refactor code, we can refactor databases, but there's another important thing that often requires refactoring, and that is the HTML that drives our websites. There's a lot of HTML out there. Often it's in a pretty iffy state, and there's a lot of things that need to be done to be able to make a lot of HTML cleaner and easier to work with, particularly as we bring in the ideas of HTML5, CSS, things of that kind. So this is another aspect of refactoring and leads naturally to another refactoring catalog. And in this case, I was very happy to get hold of Elliot Rusty Harold. I'm a big fan of Elliot's books on XML. Often when I've looked at XML processing, Elliot's who I turn to, both for his books and for his libraries. He's done excellent Java libraries to do with XML. And here he talks about how you can essentially make your HTML, drag it kicking and screaming into the 21st century. And just as clear code is an important part of programming ability, writing clear HTML is a very important part of being able to build maintainable websites. Often it can be little sideways, throwaway comments that can be quite inspirational. I know this because I sort of remember sitting in a conference many years ago, sometime in the early 90s, listening to Big Dave Thomas. We refer to him as Big Dave Thomas to separate him from Pragmatic Dave Thomas. Pragmatic Dave is the guy who did the Pragmatic Programmer and runs the Pragmatic Bookshelf company. Big Dave was the guy who founded OTI, which was a Smalltalk-oriented organization that ended up becoming part of IBM and developing Eclipse. And Big Dave is very active in promoting conferences. You can see him speak all over the place. This was a long time ago when he was still at OTI, and he was talking about Smalltalk. And I have no idea what his talk was generally about, but I do remember an offhand comment saying that any system should be able to test itself. And at the time I was doing some programming work at a client and thinking, what would that mean? And I ended up exploring with the idea of having a completely automated test suite that could test the entire application I was building completely automatically with just one Smalltalk command. And I found this to be incredibly valuable. So when I later on joined up with Kent Beck and we worked together on the birth project for extreme programming at C3, I was very encouraged by the fact that he'd had this same idea. And he'd built a little framework for Smalltalk that actually did it a lot more elegantly than I did. And then I saw it on what happens when you take a team of people and have this fully automated test suite, and saw it was really valuable. It gave you great confidence in changing the code. It's a really vital foundation for refactoring. It also greatly reduces the amount of bugs that get out into production, because you've got much more of everything you're doing is focused around testing. Now, Kent's little framework for Smalltalk was known to various Smalltalkers that he worked with, but it really became famous in, I think it was 1997. He was traveling from where he was living at the time, which was in Switzerland, Zurich, Switzerland, to Atlanta, where the UPSLA conference was being held that year. And also living in Zurich at the time was another object-oriented guru, Eric Gamma, who is one of the Gang of Four who wrote the Gang of Four book. And also Eric is known as the technical lead behind Eclipse. So you've got Kent and Eric, two very capable programmers, sitting on an aeroplane together for a very long flight over to Atlanta. What are they going to do? They're going to get the laptops out and program. Kent was interested in learning more about this newfangled Java language that Eric was really into. And Eric was very intrigued by what Kent was doing with this little testing framework. So they built a little testing framework in Java. That framework is called xUnit, and it's become an extremely influential testing framework. As well as influential in Java, it's been ported to all sorts of other languages. And hence, it's often referred to as xUnit, because everybody, of course, called their version of JUnit something unit. So there's NUnit for .NET, and et cetera, et cetera, et cetera. Now, it's one thing to have the framework. It's another thing to know how to use it well. And one of the things that people did as they started using these frameworks was figuring out how to get the best advantage from it, how to use different techniques in order to use these various xUnit tools very effectively. One of the guys who was in very early on in this effort was Jared Mazaros. And he ended up writing the book xUnit Patterns, which is another member of my signature series. I had to actually fight a bit for Gerard's book. He was originally going to put it somewhere else, and I had to really tug to get hold of it. It's a big book. It covers a lot of ground. There's a lot of depth in there. But it's actually not as intimidating as it looks. Gerard followed what I did with Patterns of Enterprise Application Architecture and made the book a duplex book, which means that it's divided into two parts. The first part is only really a couple of hundred pages, and it goes through the overview of how you use these xUnit tools. The bulk of the book is reference material, and you don't really need to read that end to end. The idea is that you read that first bit that gives you the narrative, the overview of what's going on, and then you just dive into the patterns in the reference part when you need a specific piece of information. This duplex book idea is one that I think is very valuable for organizing books that have a lot of reference-like material. I did it with Patterns of Enterprise Application Architecture. I did it somewhat unconsciously with refactoring, and I did it rather more consciously with my domain-specific languages book. So the domain-specific languages book came, as a lot of my writing does, on observing what was going on projects I tended to pop into and see at ThoughtWorks. And during the mid-zeros, I saw a few cases where we'd used small domain-specific languages to get a really good bit of leverage on a problem. Sometimes these would be issues around the technology of the system. But often these will be around areas where we're communicating with domain experts. If you want to understand complex pricing rules, for instance, it's often very valuable to express those pricing rules in a way that's understandable to someone who is a domain expert, i.e. not a programmer, but at the same time, those rules are expressed in a form that's also automatically processable and is part of the source code for your system. This idea of teasing out rules and making them visible this way forms a domain-specific language. Now, domain-specific languages can be very powerful, but they don't have to be really that complex. Often, in fact, the best domain-specific languages are really quite small things. A good example of a domain-specific language that's become incredibly popular is CSS. Most people who program in CSS don't think of themselves as programmers. They think of themselves as web designers. But they are, in fact, using quite a sophisticated DSL in order to program with. Actually, CSS is a more sophisticated DSL than I would typically see people build. But it gives you an example of what is possible. Now, with domain-specific languages, although they've been around a long time, and we use them as programmers all the time without even thinking about it, regular expressions of DSLs, all sorts of things are DSLs. What there isn't is very much advice on how to build one, because there's a lot of different techniques out there. And often when I saw people working with DSLs, they were doing good work, but they didn't know the full range of options available to them. And that's what launched me on my journey to write the Domain-Specific Languages book, was really to provide a book that would really show all the options available to people who work with DSLs. In order to build a DSL, you don't need sophisticated tools. You actually don't need a huge amount of fancy knowledge about compilers and language theory and the like, but a little bit of it can help you a good way. So the idea of the book is to provide that. Like a couple of other books in the series, it's a duplex book. So although it's quite a thick book, really only the first 150 pages are the mandatory reading. That's the stuff you do really need to read end to end. The rest of the book is reference material, and you only need to dip into that as you need it. But what I think the book can help you do is figure out whether DSLs are an appropriate approach for aspects of your project. We're never going to see a whole system built in DSL, in a single DSL. It's something you use for parts of the system, and then gives you an idea of what techniques you can use to implement that. This aim of producing a domain-specific language that can act as a communication medium between you and a domain person, it's not easy to pull off, but if you can, it can be incredibly valuable. So it's often worth trying.